So for today, we are going to discuss two things, index families of sets and Cartesian product. So first, let's discuss index families of set. Here, we are going to define what we mean by index families of sets. Of course, we're going to extend the definition of elementary set operations in arbitrary union, arbitrary intersection, and arbitrary complements. That's why it's very important that the definitions and the properties discussed and shown in the module for union, intersection, and complement are crystal clear para yung pag-generalize natin will be as smooth as possible. Yung union, intersection, and complement kasi is applied just in two sets, but here we're going to extend them in arbitrary family of set. Okay? So if you're ready, let's start. Siyempre, simulan natin sa definition. So ano ba ibig sabihin ng arbitrary family of set or index family of set? So let gamma be a set. So this gamma is our notation for an index set. Yeah. Or indexing set rather. So that's a Greek letter gamma, capital gamma. Yan. So to write gamma, gagawin mo lang, gagawa lang ng pababa. And then parang caret lang. Ayan. Okay, so that's the Greek letter gamma. The small letter gamma is written this way. Yung gamma, yan yung parang third angle when you write the angles of a right triangle. If you remember, pag nagtuturo ng trigonometry, usually ang ginagamit na angle ay alpha, right? Alpha, beta, yung pangatlo, yan yon, yung gamma. So, it's a small gamma. That's a Greek letter gamma. Okay? Ayan. So, yung gamma naman, yung small gamma naman, para siyang ribbon. So, yung capital gamma we will use to denote a set, and the small gamma we will use to denote the member of that set. So, let gamma be a set, and assume that for each gamma, we have an associated set A sub gamma. So the family of all this set, yung collections ng mga A sub gamma, for all gamma in the indexing set, is what we call an indexed family of sets. So again, the collection of all this set A sub gamma, defined for each gamma in the indexing set, is called the indexed family of sets, which is indexed by gamma. So we call gamma an indexing set. Now, parang medyo technical yung definition, but really it's very simple to understand. Okay, think of the indexing set as the index card in an old or classical setup of library. So kung nakapunta na kayo sa mga lumang library, yung hindi pa modern na may computerized. Okay. For example, you can visit the old library in UP Diliman, or baka meron din yung mga library natin dito sa Bulso. Pero ngayon kasi ang mga library usually mga modern library na, computerized na. Pero before, okay, if you want to borrow a book from a library, what you do is you go to the index files. So merong box or merong listahan ng mga libro, and each book is associated with an index card. So ano yung matatagpuan sa index card na yon? Nandun yung tinatawag nating brief information about the book, specifically the call number. Sa hardbound book kasi, makikita nyo sa likod niya, meron dong white paper sa taas, tapos may nakasulat na call number doon. So the call number is unique for each book. The call number is an indexing system ng library to arrange informations about the book. So kung manghihiram ka ng book, kailangan alam mo yung call number. Or if you want to find a book, you go to the closet. Maraming closet yan ng mga index card. Tapos iisa-isahin mo yung files ng index card para mahanap mo yung libro na gusto mong basahin. Again, right now, since modern times already, computerized na yung estante na to is stored already in a computer system. So, meron tayong online repository ng index card. Pero ganun pa rin yung concept. So, ang concept, meron pa rin siyang call number and it contains all the information about the book. So, ano yung sinasabi ko doon sa set natin? Yung index card natin, yun yung indexing set. Okay? And the informations or the book itself is yung mga set. So, for example, meron kang book with a call number. This is just an example. The usual call number for a math book is QA, tapos 4-digit followed by another 4-digit and then a 2-digit number. So, that's the usual call number of a math book. So, this particular value is unique to that book. So meaning each book is attached with a unique call number. So call number is your index for that particular book. So the set of all the indices or these call numbers is your indexing set. So in the modern terminology, ang indexing set pala is nothing but hashtags. Yan, para mas millennial ang dating. So pag meron tayong mga informations na gusto nating i-collect, nilalagay tayo ng hashtag. So para malaman natin na yung hashtag natin, yun yung pang-denote natin dun sa lahat ng informations about that particular hashtag. Yan. So ang ginagawa natin, we're issuing a unique identifier sa set natin. So our set A is being identified by a unique sigma or gamma rather coming from this indexing set capital gamma. Okay? So ganun lang ang idea ng indexing set. Nilalagyan mo lang ng unique identifier yung set. Okay? Yung unique identifier mo are the elements of your indexing set and for each element in the indexing set there is an associated A sub gamma. Now, this collection is called the family of sets. So, recall again, when we say family, what we mean is a collection of sets. Set pa rin siya, pero ang mga elements niya, mga set din. Okay? So, again, a family of set can be indexed by an indexing set. But the requirement here is that kung ilan yung i-index mo, dapat ganun din karami yung pang-index mo. Let's have some example. Let's say we have a family of sets consisting of this set. The set 1, 2, the set 2, 4, the set 3, 6, and so on. So in general, the set consisting of the elements n and 2n. So since intuitively, we know that there are infinitely many sets of this form, di ba? 1, 2, 2, 4, 3, 6, 4, 8, and so on. So, infinitely many. But, what we can see for sure is that yung ating set defined by a natural number. So, we can let our indexing set to be the set of the natural number. And we can define each A for our set as follow. So, for n equals 1, i-define natin yung A1 as the set 1, 2. For A equals 2, i-define natin yung set natin as the set 2, 4. Of course, for A equals 3, i-define natin yung set natin as 3, 6, and so on. So, meron tayong pang-index for each n in the indexing set, in gamma. So, A sub n is the set n, 2n. So, every element of our collection, every set here in our collection is being indexed by a natural number n. So, that means our set, and let's call it script F. So, usually for family, we're using a script letter to differentiate it from a usual set. Again, this is still a set, but with a special property, the elements of this set are set themselves. So the family can be shorthand written as A sub n for all n in our indexing set, which is the set of natural number. So therefore, this set is indexed by the set of natural number. Okay? So meaning it's just a shorthand notation on how we represent the set. Pero yun pa rin yung rule method natin. You define the elements of the set and then you give the property of that particular element of the set. Yeah. So here, we defined where a sub n, of course, is the set defined by n, comma, 2n. Okay? Indexing a set is more appropriate when you have multiple elements that need to be properly labeled. But of course, it doesn't restrict us from using indexing set in set containing just few or finitely many elements. For example, meron tayong set, the family of set containing the empty set, the set of natural number n, set of integer z, set of rational number q, real number r, and complex number c. So all in all, we have 6 different sets as a member of the collection F. So how do we index this set? So ang rule lang naman ng indexing set, kailangan the indexing set must be of the same size of the set being indexed. So, since meron tayong 6 na i-index, we just need to find a set with 6 elements na pang-index natin. So, generally speaking, you can, or more conveniently, you can choose the set containing the numbers 1, 2, 3, up to 6. And then, conveniently define A1 as the empty set, A2 as the set of natural number, A3 as the set of integers, A4 as the set of rationals, A5 as the set of real, A6 as the set of complex number. So now we can redefine the family as being indexed by gamma. So this is defined as A sub I, where I is coming from the indexing set 1 to 6. Okay? Ayan, ganun lang kasimple ang ibig sabihin ng indexing set. So the indexing set is gamma and the index set is the family. So we always, or we usually use this when we have an arbitrary family of set. Okay, so now let's try to extend the definition of union in arbitrary collection of sets. Okay. So let script A be a collection of set. The arbitrary union of set in script A is the set of all elements which belong to at least one of the set A in our collection A. To illustrate that in Venn diagram, ganito lang yung nangyayari. So, meron tayong collection of sets. For example, set A1, A2, A3, yan, mga A's yan. Mga A element of the collection A. So, what we mean by union is any X belonging to any of these A's belong to the union, belong to the arbitrary union. Very similar to two sets. Di ba? Two sets, kukuha ka lang either it's in A1 or in A2. All of them belongs to the union. So, ganun din. Lahat ng element nitong set na to, together with the elements of this set, together with the elements of this set, together with the element of this set, together with the element, and so on, kung gaano man kadami yung A mo. So, all of those object X belongs to the arbitrary union. So, this is all object X such that X is an element of A for some A in our collection. So that's what we mean by arbitrary union. You just have to make sure that the object X belongs to one of the collection. At least one. Pwedeng madami. Pero for as long as there exists. Yan. So there exists. So that can also be written as there exists an A in the collection such that X is in that A. Yan. So if X satisfied that particular condition, then X belongs to the union. Now, if the arbitrary collection is being indexed by gamma, so let's say we have the collection is indexed by gamma, so we can write that particular union as follow. So instead of A lang, lalagyan mo na siya ng index niya, A sub gamma. Now this time, ang condition, gamma is from our indexing set, capital gamma. So to write that, we have all object X such that X is in A sub gamma for some gamma in the indexing set. So they are basically equivalent statement. Ang pagkakaiba lang, yung second statement is being indexed by gamma. So in reference to gamma, you have the set A sub gamma. Okay? Now, in a simpler setting, what if yung gamma mo lang ay finitely many set? For example, yung gamma mo 1 to n. Or meaning, the collection consists of the n sets A sub 1, A sub 2, and so on up to A sub n. So you have n different set, a collection of n, not necessarily different pala. Pwede magkakamukha yung set. So basta mayroon kang collection ng n sets. Yan. So, the definition becomes X such that, so i-retrofit lang natin yung definition dun sa gamma natin. Since ang gamma natin 1 to n lang, so ang requirement lang naman niya, X must belong to any of those. So, X belong to A sub I for some I in our indexing set. Well, of course, kung n finitely many set, that's also equivalent to A1 union A2. And then the union of that, union mo sa A3. And then yung sagot, union mo sa A4 and so on up to the last set A sub n. So inductively, it can be extended to n sets from the case na dalawa lang yung set. And so that's how we define arbitrary union. Now, how do we define arbitrary intersection? So suppose we have the same collection, arbitrary collection of set, script A. The arbitrary intersection of set in A is the set of all elements which belong to each of the set A in the script letter A or in our collection. So, same case with two sets, you need to satisfy the condition that X must be a common element. It must be on the first set and it must be on the second set. So, kung marami ka ng set involved, so that's your collection. So, ang sisiguraduhin mo lang, yung A dapat na kay A sub 1, yung A dapat na kay A sub 2, yung X dapat na kay A sub 3, and so on. So, yung mga element mo na nasa intersection, dapat nasa kada isang set sa family. So, by definition, we can write that mathematically as all object X such that X is in A, this time for all. For all A in our collection. Yan. So, in shorthand, that can also be written as for all A in the collection, we have X in A. Dapat sa lahat, sa kada isa, for each or for all. Para lang ibig sabihin yan. Kanina for some lang. Ibig sabihin, kailangan may makita ka lang kahit isa man lang na nandun si X. Pero ito dapat sa lahat ng A na nasa collection, nandun dapat si X. Yan. Now, if A is indexed by gamma, so we can write each element A as A sub gamma. So we are getting the intersection A sub gamma for all gamma in the indexing set. So to write that in our mathematical expression, we say X, an object X such that X is in A sub gamma for all gamma in our indexing set. Or mathematically, dapat for all gamma in the indexing gamma, dapat X is in A sub gamma. Okay? So, ang difference lang ng intersection of union, yung kaninang and, yung kaninang union or for some, so let me reiterate that, this is the equivalent of or. Kasi A or B tayo, di ba? Remember, A or B ang union. So in general, pag marami na yung set, ang ibig sabihin ng A or B or C or D or F, ibig sabihin nun for some. Yan, yun yung general terminology ng or. Pero pag end naman, so ito counterpart to ng A intersection B, di ba? So end yan. So A, nasa B. Yan, yun yung ibig sabihin nun. Nasa A, nasa B. Yan, baliktad ako. Dapat nandito yung A intersection B. So, ano ibig sabihin na si X na kay A, na kay B, na kay C, na kay D? Ibig sabihin nun, for all. So, the general terminology for end is for all. Okay? Yan. So, huwag nyo kakalimutan, yung end, pag generalize mo, magiging for all. Yung or, pag generalize mo, magiging there exist. Yan. Sila yung magka-counterpart. Alright. Now, what if the indexing set is 1 to n? Again, meaning the collection consists of finitely many sets A sub 1, A sub 2, and so on up to A sub n. Okay. So, paano mo kukunin yung intersection? So, generally speaking, ang ibig sabihin nun, X is an object such that X is an element of A sub I for all I in the indexing set. So, inductively, from intersection of two set, ang ibig sabihin nun, A1 intersection A2, and then yung result, i-intersect mo kay A3, and then yung result, i-intersect mo kay A4, and so on, and so forth, until you get the last set. That's how we define finitely many intersection. So, ang tawag dito sa dalawa na to, since arbitrary yung set natin, arbitrary intersection. This is arbitrary. Pero dito, since finite naman yung intersection, tatawagin natin siyang finite intersection. The difference is the indexing set or the number of elements contained in the family, in the collection. So, if you're not sure how many elements are there in the collection, then you say it's arbitrary. But if you're sure, then you say it's finite. Kung alam mo, kung mabibilang mo lang kung ilan lang sila. Ganun din sa union, of course. We call it an arbitrary union, while this one is called a finite union. This is also arbitrary, yung pangalawa ha. Pero this time, it's being indexed already. Indexed by gamma. Pero arbitrary pa rin siya kasi hindi natin alam kung gaano kadami yung ini-intersect or ni-union natin. Okay? Let's have some example. Recall in algebra, open interval or in calculus, kung saan nyo man siya ginamit. When I say open interval, AB, ang ibig kong sabihin na is the set containing all real number between A to B. So to imagine that in a number line, gagawa ka ng number line, so anything in between, yan. Not including the endpoints. So the segment A to B, not including the endpoints. On the other hand, pag sinabi mo namang close interval, ang ibig sabihin nun, you have all element X from A to B. All real number from A to B. This time, including A and B. So if you draw that in a number line, so this is A and this is B, all points in the segment A to B, including A and B. Now, we also have half open and half close interval. Pwedeng open left, close right, or open right, close left. So, open interval AB, close sa B, is the set of all points X between A to B, not including A. So, this is not equal to A, pero equal sa B. Okay? So, sometimes ang ginagamit nating notation, ganito, yung open parenthesis tapos close bracket. So, pwedeng ganun din ang pagkakasulat mo nung number line. So, bracket to bracket meaning kasama yung endpoints. Okay. Open to open. Yan. And finally, yung kabilang half open, half close interval, all real number x between A to B, including A, but not B. So, it includes A, but it doesn't include B. Okay? So, again, these are the open intervals that you know from algebra or calculus. Just to make a distinction, do not confuse this one with ordered pair. Yan. So, minsan kasi syempre may mga ordered pair tayong na-encounter. So, just to avoid confusion, you should always clarify whatever set we are talking about or we are dealing with. Okay, so ito example. So, suppose we have the family of sets close interval 0, 1, close interval 0, 3 halves, close interval 0, 5 thirds, close interval 7, 4, and so on. It's easy to figure out kung ano yung pattern. Yung denominator, magsisimula ka sa 1 over 1, over 2, over 3, over 4. So, over n yung denominator. Tama ba? Over n. So, 0 up to over n. So, ano naman yung numerator? So, yung numerator, 1, 3, 5, 7. So, mga odd number. So, how do you represent those odd number? So, 2n minus 1. Okay? Now, let's try to visualize yung given set natin. Let's try to visualize them. Okay, A1 is just the set 0, 1. So, if we visualize a real number line, let's say this is a number line, let's say this is 0 and this is 1. Let's say this is 1 and this is 2. Yan. So, nasaan yung A1? So, A1 is represented by the segment from 0 to 1. So, we're starting from 0 and then we'll end up with 1. That segment is A1. Now, what about A2? So, A2 is the segment 0 to 3 halves. So, if you imagine, this is a segment from 0 to 1 and a half. So, 1 and a half is in between 1 and 2, right? So, this is 3 halves. So, from 0 up to 3 halves, including the endpoints because these are close intervals. Right? So, parang lumaki siya. Yan. 0 to 1 yung kanina, ngayon 0 to 1 half na. This is up to 1, this is up to 1 half. A3 is 0 to 5 thirds. So, what's 5 thirds? That's 1 and 2 thirds. So, 1 and 2 thirds. For example, hatiin natin sa tatlo to, you get 2 thirds. So, somewhere here. Yan. So, this will be your third set. All points in between those line segment, including the endpoints. So, that's 1/3. In general, let's skip to the general part. So, all you need to do is to find 2n minus 1 over n. Ibig sabihin, all you need to do is to divide the segment into n, di ba? I-divide mo lang into n segments, equal segments, and then get the 2n minus 1 is yung pinakahuli na segment. Aalisin mo lang naman kasi this is equal to 2 minus 1 over n. So, tatanggalin mo lang yung huling 1 over n. Right? Yan. So, this is 2n minus 1 over n. That's actually less than 2. Hindi pa yan naabot ng 2, ha? Yan, just to be clear. So, this is less than 2. So, you can imagine that we have what we call an expanding set or interval. So, nag-expand siya. Palaki ng palaki yung interval. So, what happens if we get the union, arbitrary union of this set? Now, let's take a look at A1 and A2. If you take a look at A1 and A2, clearly, Yan, clearly, di ba? A1 is a subset of A2. Lahat nung nakay A1, nakay A2 din. So, subset siya. Right? Kasi si A1 hanggang 1 lang eh. Hanggang dito lang si A1. Pero si A2 hanggang 1 half pa. So, subset siya. Similarly, si A2 subset ng A3. Yan, very clear yan ha. Hanggang dito lang si A2 pero si A3 may dagdag pa. And so on. So it is easy to show that our expanding interval follow this series of set inclusion. A1 is a subset of A2, A2 is a subset of A3, and so on. So what happens if you get the union of this set? Diba? Halimbawa lang, hanggang 1 to n lang yung kukunin mong union. O for example, A1 union A2 muna. Since si A ay subset ni B, syempre, pag ni-union mo yung dalawa, if you remember the properties of union, ang A union B, ang A union B must be equal to, si A, subset lang siya ni B eh. Nasa loob si A ni B. So, pag ni-union mo siya kay B, si B pa din yung sagot, di ba? Recall natin yan, ha? So, that's why it's very important na naiintindihan nyo yung elementary set operations. So, kung meron kang series of set inclusions A1, subset ni A2, subset ni A3, automatic yung A1 union A2, ang sagot A2. Yung A1 union A2, union A3, A3 kasi palaki lang naman ng palaki yung set eh. So, ang union ng I union I equals 1 to n must be the last set, A sub n. Right? Okay. Now, what happens now if we get the union of all the set in the collection? Remember, up to n lang yung in-illustrate natin. But the collection never ends. Infinitely many yan. So, ibig sabihin, what if we get the union of A sub n for all n in the set of natural number? So, ano mangyayari? Now, taking a look at the right endpoints, kung mapapansin natin yung right endpoint, from our previous knowledge from calculus, intuitively, di ba ang 1 over n, this approach 0 as n approaches infinity. Yan. So, if that approach 0 as n approaches infinity, ibig sabihin yung set na to, palapit ng palapit dun sa 2. Di ba? Palaki ng palaki siya, pero palapit siya ng palapit sa 2. So, yung an natin, palapit ng palapit sa 0, 2. But, since this is less than, it can never be equal to 2. Never mag-i-equal sa 2, right? So, ibig sabihin, dapat open parenthesis sa 2. Kasi it will never be equal. Pag not equal, ang ginagawa natin, half open. Alright. So, intuitively, we guess pa lang ha, guess. We guess that an will approach 0, 2. So, we're claiming now that it is indeed 0, 2. Now, it's a claim. So, it requires proof. Yan. Hindi natin pwedeng sabihin intuitively sure. Diba? Nandito nga tayo sa set theory. Ang purpose nga natin dito, mag-prove. Again, I always remind everyone, in set theory, what we do here is we prove the properties of set. Alam na natin yung mga set na yan. Alam na natin yung mga properties na yan. Ang concern natin, paano siya i-prove. Okay. So, let's prove our claim. So, we are claiming that this set is actually the set 0, 2. So, how do we prove our claim? We use the definitions. Okay. So, we want to show equality of two sets. Again, remember, when you want to show that two sets are equal, always remember the definition. A is equal to B if and only if for every x in A, dapat yung x na yon na kay B. And for every x in B, dapat na kay A din yan. Yan. That's how you prove set equality. Alright. So, we want to get an object x from the union A sub n coming from infinity. So, what does that mean? So, by definition of arbitrary union, it means that x is an element of A sub n, right? For some. Kasi union eh. for some n in our indexing set. That's the definition of arbitrary union. Okay. So if X is an element of AN and we know that AN, again, how do we define AN? AN, let me write it here. AN is defined as 0 to 2n minus 1 over n. That's our AN. So meaning X is in that set. So this means that X is an element of the interval 0 to, again, that's 2n minus 1 over n. That's the given. Right? Okay. So that means, by the definition of interval, X must be between 0 to 2n minus 1. For some n. Okay? For some n. There exists an n. Yan. For some n. Okay? So this is definition of interval. Alright? Now, what does it mean for x to be between 0 to 2n minus 1 for some n? Remember, yung 2n minus 1, again, yung 2n minus 1 over n is the same as 2 minus 1 over n. So, anong ibig sabihin na si x is between that value? Mula dyan hanggang dyan. For some n. Ibig sabihin, meron kang makikitang n. Sa x na yon, meron kang makikitang n. So, no matter what happen, kahit ano pa yung value ng x, never namang nag-i-equal to sa 0. This is never equal to 0. So, the whole thing is never equal to 2. Right? So, this means that x definitely is between 0 but less than 2. Definitely. Right? It can never be equal to 2. So, inalis natin yung n, yung 2n minus 1 over n. Right? So, that means that x belongs to the interval 0 to 2, which is what we want. Therefore, the original set A sub an, n is the set of natural number for our indexing set, is equal to the interval half closed, half open, 0, 2. Okay? So now we're sure that the union is 0 to 2, not including 2. So we use a concept from calculus to visualize intuitively para ma-imagine natin ano nangyayari. And then we prove it using the properties, using set properties. Okay. Let's have another example. This time, let's give it a shot for arbitrary intersection. What if we have the open intervals 0, 1, 0, 1 half, 0, 1 third, and so on? Again, intuitively, this is an unending set. So, intuitively, pwede nating makuha yung general formula, that's 0 to 1 over n. Yeah. So, let's imagine again our set. A1 denotes the set 0, 1. So, paano natin may imagine yung 0, 1? So, let's have a real number line. Let's call it, let's say this is number 0, this is the number 1. So, A1 is simply all the numbers from 0 up to 1, not including the endpoint. So, I'm using parentheses to denote it's not including endpoints. A2, on the other hand, is 0 to 1 half. So from 0, you get 1 half. So up to this point. A3, just to get a general feel of what's happening in our set. So you get 1/3. So 1/3, more or less. So 1/3. So now, we have what we call a shrinking interval. Shrinking, nagsishrink. So from the original interval, paigsi lang siya ng paigsi. Well, in general, that's AN. right? So we have 0 on the left interval, and then in general, meron tayong 1 over n. So this is 1, this is 1 half, this is 1/3. In general, 0 to 1 over n. Now, few observation. Since the set is shrinking, so that means that A1 contains A2. Diba? This is A1, mas mahaba. Yung A2 hanggang dito lang. Ayan lang yung A2 eh. Yan. Yung A3 hanggang dito lang sa 1/3. So, ibig sabihin, yung buong A3 contains siya sa A2. Baliktad yung relationship natin. Ganon din yung A4 and so on. Paliit ng paliit yung set natin. Paliit ng paliit. So, what will happen if we get the intersection? So, halimbawa, kunin natin yung A1 intersection A2. So, pag ginawa mo A1 intersection A2, syempre, since mas maiksi yung A2, yung intersection ng dalawa up to A2 lang. Right? Yung intersection ng A1, A2, intersection A3. So, yung A3 hanggang dito lang sa side na to. So, hanggang dito lang yung makukuha natin. So, paliit din ng paliit. So, in general, the intersection, right, from A1 to AN, makita natin from our observation, so intersection ng AI ay coming 1 to N, ay nawala yung intersection symbol. Intersection ng AI is the last set AN. So what happens to the set? Ano nangyayari pagka yung N natin approaches infinity? Now again, intuitively, from calculus, we know that since 1 over N approaches in 0, as N approaches infinity, so yung AN natin, nagiging yung left side niya 0. Ito yung right side niya 0 din. So, it's no longer an interval kasi ang left endpoint niya 0. Ang right endpoint niya 0. To make it worse, hindi pa kasali yung endpoint. So, how do we represent that? It's an interval containing no points, tapos hindi pa kasali yan. Yung point na yan, yung endpoint, di wala na talagang laman. Or that's the empty set. Right? Palit na palit yung interval eh. Okay? So again, we're claiming that ha. Hindi pa natin sinasabi na yan nga ang sagot. So we are claiming that this is actually the empty set. So how do we prove that? Again, it's a claim ha. Now, as I've mentioned when we discuss empty set, the empty set is defined as all element containing all element x such that x is not equal to x. Meaning, it contains contradicting elements. So that's the easiest way to show that a set is empty. Say that it has an element and show that that particular element is actually not in that set. So meaning, wala siyang laman. So, we will assume that the set is not empty and we will show that if it is so, then we have a contradiction. So we're going to prove this by contradiction. That's the usual way to prove that a set is empty. Okay. So we're going to assume that the set is not empty. So we are proceeding by contradiction. So the proof is by contradiction, ha? So you remember your technique when proving by contradiction back in FCM. Diba? When you assume the negation of the conclusion, then you need to find a contradiction at the end. Pag nakakita ka ng contradiction, then your assumption is wrong. So the opposite of that assumption, yun yung true. So we are going to assume that it is not empty. So suppose the intersection of AN for all integer n is not empty. So that's the assumption. So meaning it has an element inside. So let x be that element. Yan. Okay, so from this, we can now give some normal conditions for x. So, ano mga conditions kay x dahil nandun siya sa intersection? Of course, since x is in the intersection, then x, let me write it again, X is in the intersection an for all n element of the natural number. So that means that X is in an for all n. That's the condition of intersection, arbitrary intersection. Now, what if X is in an? Again, what's an? We define an to be the set containing all points in the interval 0 to 1 over n, not including the endpoints. So that means X is between, not including endpoints, so 0 to 1 over n. Right? That's the given. So, an is defined to be the interval 0 to 1n. So that means that x is between 0 to 1n, not including 0 and 1n. Meaning, x is greater than 0. Right? That's what it means. So if x is greater than 0, by what we call the Archimedean principle, ganito lang sinasabi niyan. Pag meron kang number, if you have a positive number, okay, so meron kang 0 to a, positive yung a. Sabi ni Archimedes, merong natural number such that yung 1 over n, mas maliit pa dyan. So sinasabi lang niya, there is a rational number between 0 to a. So very easy to understand. Whenever you have a positive number a, so a is greater than 0. There's always a 1 over n between 0 and a. Laging meron. Lagi kang may makikitang capital number, n is a natural number, by the way. So, lagi kang may makikitang natural number n such that 1 over n is smaller or in between 0 and a. So, since x is greater than a, by the Archimedean principle, here our a is x. So, by the Archimedean principle, we must be able to find a natural number n such that, ano ibig sabihin? Si 1 over n mas maliit kay x. Yan. Now, what will it mean? Of course, 1 over n is greater than 0. So, what will it mean? If 1 over n is smaller than x, then x definitely will not belong to the set 0 to 1 over n. Definitely, kasi 1 over n is smaller. Right? So, we were able to find a set where x does not belong. Yan. Wait. This set 0, 1 over n, isn't it true that this is a sub n? Right? That's a sub capital N. Because that's how we define a sub n. That's the open interval 0 to the endpoint. Right? Now, we're saying that x does not belong to that set. That's absurd. That's a contradiction, right? Why is it a contradiction? Because we assume from the beginning that x is in the intersection, then x must be in a sub n for all. We shouldn't be able to find any a sub n where x does not belong to. But we were able to find one such a sub n. So that contradicts our assumption. So by proof of contradiction, the supposition is false. That must be false. So its negative must be true. Tama? Its negation must be true. So therefore, ang totoo pala, hindi yan yung totoo. Kasi may contradiction eh. So ang totoo pala, therefore, yung intersection of AN must be empty. And we are done. Okay? Alright. So we were able to show that the intersection of this shrinking set, palit ng palit yung set, hanggang sa magtagpo na yung dalawang endpoint is actually empty. Now, what's amazing about this fact is each A sub 1 actually is not empty. Not empty yan, di ba? Not empty. Not empty. Every interval, no matter how big n is, even if n is 1 billion, 1 trillion, 1 quadrillion, 1 gazillion, there's still points in between 0 and 1 over n. So no element of the collection is empty. Wala tayong set na empty. Pero nung in-intersect natin, empty ang sagot. That's what amazing about that. Diba? So, paliit tayo ng paliit, pero hindi naman tayo nagiging empty. Paliit lang tayo ng paliit, di ba? Paliit lang ng paliit, pero never magiging empty yan. No value will make that empty. But if we get the intersection of this non-empty set, how come the result is empty? So, it's possible. It's possible that the intersection of a collection of non-empty set. So, it's possible that a collection of remember, these are overlapping sets. Pwede kasing i-argue ng iba na, sir, baka at some point, hindi na nag-overlap yung set, kaya empty na yung intersection. No. The sets are overlapping. Paliit lang ng paliit di ba? So, overlapping yung set. You get any two different A sub n, may intersection yan. The intersection is non-empty. Right? The intersection is non-empty for any two sets. For any two set, the intersection is not empty. For any set, it is not empty. But if you get the intersection of all these sets, the intersection is empty. Okay. So that's how amazing and mysterious infinity is. That's what happened if we get all the sets as n approaches infinity. So it's possible because of the mysteries of infinite number. And that's what amazes Cantor as well. Yan. Kaya inaral nilang mabuti yung concept na to ng set theory. Okay. Cantor, Dedekind rather. Okay. And yun yung hindi naunawaan ni Kronecker, if you remember the introduction of set theory. Si Kronecker ay very antagonistic to Cantor and Dedekind. Buti na lang sinuportahan sila ni Hilbert. Hilbert is a very prominent mathematician in the 1900s. Pero si Kronecker, lahat ng power niya ginamit niya so that Cantor will have a miserable life, di ba? Parang pinigilan niyang ma-publish yung mga work ni Cantor, pinigilan niyang ma-accept si Cantor sa Berlin University because hindi niya mag-grasp yung concept ng infinity, ng infinitesimal. Yan. Okay. Enough of history. Sige. So now let's generalize the De Morgan's theorem. To generalize De Morgan, baka nakalimutan na yung De Morgan. So again, De Morgan is A except B union C is equal to A except B. Parang dinidistribute mo lang yung complement, A except C, and then you get the intersection. That's the De Morgan for set. There's two versions. That's A, B intersection C is equal to A except B, and then get the union with A except C. Alright. So if you generalize that, instead of just a B union C, we're going to get the arbitrary union. So you get as follow. Let U be a set and let A be a subset of U. So we have a collection of subsets of U. Okay? So for the sake of illustration, let's say we have this U as our universal set and you have A all over U. Okay, so that's your collection of sets. So what we're doing here is we're getting the union of this set. So you get the union, you get the union, you get the union. And then you get the complement. That's what we mean by U except, diba? The universal set except that set. So you're getting the union. So what we want is the complement of that union. So anything outside the union. So this is what we call the union of A, and then you get the complement. So you can have that representation as well. Now, what De Morgan is saying is that it is also equal to get the complement of each first. Kunin mo muna yung complement ng kada isa. Let's do it in two sets muna para hindi nakakalito. Pareho din daw yan sa ang gagawin mo, halimbawa, meron kang dalawang set, di ba? Complement mo muna yung kada isa. So, complement ko muna siya. So, ito, complement ng unang set. And then, complement ng pangalawang set. Kunin natin complement ng pangalawang set. So, ang sabi niya, pag nakuha mo na yung mga complement, then, you get the intersection of those complement. Well, nasa na intersection? Yung common, yung na-shade ko twice. So, actually, the intersection is anything outside the two circle. Ito yun. Right? Which is exactly the same kung paparamihin pa natin yung set. So, meaning, ang kukunin mo, anything outside the union. Di ba? So, the two processes are the same. Whether you get the union first, and then you complement, yung ginawa natin dito, or you get the complement first, and then you get the intersection of those complement. So, nababaliktad. Pag pinasok mo yung complement sa loob, so magkaka-complement lahat, but the union becomes an intersection. That's De Morgan's rule, di ba? Again, that's from the De Morgan's theorem sa logic. Yung end nagiging or, yung or nagiging end. Once ipinasok mo yung negation. This complement here is actually the negation, di ba? Not a member of. Yan. So, these two are equivalent. Pareho lang yan, ha? What we do here is, since we are already established kung ano yung U, we can just disregard kung ano yung U. Basta we have a set containing all of them. That's what U is. Kung nasaan man yung mga A sub gamma na yan. Yan. Okay? So on the other hand, kung intersection naman ang given, so you have an arbitrary intersection and then you get its complement, that's also the same as you get the complement of each first, then you get the union. Okay. So, nababaliktad. Exactly De Morgan's rule. Yung union, pag kinomplement mo, magiging complement ng kada isa, then you get the intersection. Yung intersection, pag kinomplement mo, then ang gagawin mo, i-complement mo kada isa, and then get the union. Alright. So, let's prove the first one. So, this is just the extension of the De Morgan's rule. So, we're just going to use the same technique that we use in proving De Morgan's theorem, but this time we're going to generalize it in arbitrary form. So, if we want to show that this is equal to this, or let's just use this form. So, we want to show that every element of the first set is an element of the second set. So, let's start with the left-hand side. So, let's say that X is in the element of the complement of union, arbitrary union, A sub gamma for all gamma in the indexing set. So, what does that mean? Now, since X is in the complement, then it's not in the union. Right? If it's in the complement, it's not in the union. So, since X is in the complement, then X is not part of the union of A sub sigma gamma for all gamma in the indexing set. Again, that's definition of complement. If you're not in the union, then you're in the complement. If X is not in the set, then you're in the complement of that set. But what does it mean for you to not be in the union. Now, we do not have a definition for not in the arbitrary union. Ang meron tayo, in the. So, we're going to use negation first. We will remove the negation in the union. So, this is equivalently saying that it is not true that X is in the union. It is not true. So, that's the definition of negation. Again, we cannot use the definition of union right away because we do not define X is not in. What we define is X is in. So we need this form, not this form. So we're keeping the negation outside. So this means that it is not true that X is in A sub sigma for some sigma in the indexing set. Again, that's the definition this time of arbitrary union. So now we can use De Morgan's rule. So how do you negate a statement? So this statement means, remember, this statement means there exists a gamma in the indexing set such that X is an element of A. Right? So that's what the statement means. So how do you negate that using De Morgan's rule? So by De Morgan, that's the same as if you negate there exists, that becomes for all gamma in the indexing set, and then you negate the condition X is not in the set. So for all gamma, X is not in the set. That's De Morgan. Now, what does it mean that for all gamma, X is not in the set? Then for all gamma, X is where? X must be in the complement. Definition of complement. All right. So if you're in the complement for all, then you must be in the intersection of all these complements, right? For all gamma in the indexing set. All right. So we're done because that's what we want to show, that you are in the intersection. So therefore, so this is definition of intersection, arbitrary intersection. Therefore, the left-hand side, union of A sub gamma, gamma from the indexing set, and then you get the complement. That's the same as you get the complement of each set, and then you get the intersection for all gamma in the indexing set. Again, I'm leaving 2 as an exercise because what you're going to do is basically the same as what I did. You need to do your exercises so that you will be reinforced. Kailangan ma-reinforce yung method of proving sa inyo. Kung hindi nyo gagawin yung exercises, hindi ma-reinforce. Hindi nyo matututunan. So, you need to be able to state the proof in your own words or your in your own, so that you know kung naintindihan mo ba o hindi yung proof na ginawa ko sa class or sa discussion. Of course, we also have a generalized version of the distributive law. So to review again, distributive law, we have A intersection quantity B union C. You're distributing intersection over union. So that's equal to A intersection B, A intersection C, and then get the union. You also have the same version for union over intersection. So A union B intersection C is the same as A union B, distribute union, A union C, and then the result, get the intersection.
Hindi pa naman.
Okay, so we're going to replace this by arbitrary union. So that means you can get the intersection of each. Intersection. So if there are arbitrary set, get the intersection. Intersection. And then you get the union of all those intersections. Okay.
Papasabay ko na lang. Pero tama, right
Next,
side yun. Left side
if
po yung
you
nakabuo
have
sa
B
akin.
intersection C,
Sige.
so you have intersection.
Oo, right side po yung may damage. Yung nasa, side ng passenger. Okay.
So distribute
Ay, sige po,
union, so you
sige,
get A union B, A union C. So the union of each arbitrary set, A union, A union, A union,
Oo, sige po. Send ko po
rather
tapos
this
ipapadaan ko
should
doon
be
kasi yung copy ko
intersection.
na
And then
isulat
finally,
ko
get the
na
intersection.
nakabuhay. Kasi
Okay?
papatingnan na ba namin doon sa
So I'm going to prove number 1 and I will leave number 2 as an exercise. So this will be an exercise.
Iba kasi magdadala yung sister-in-law ko na lang. Okay, sige.
Alright. So what we want to show is this equality. So for every x, what does it mean that x is in this intersection? A intersection U, B sub gamma, gamma element of the indexing set. Alright. So we can apply first the definition of intersection. So that means that x is in A and x is in the union. That's definition of intersection. Now, applying the definition of arbitrary union, we have, let's copy x is in A, and we have the compound statement, x is in B sub gamma. Since this is a union, so we use for sum. For sum, U, rather gamma in the indexing set. So that's the definition of arbitrary union. Now, remember that arbitrary union means it's or. It's an or statement. All right. So we have an and statement distributing over or statement. So by the distributive law, that's just x is in A and x is in B gamma for some gamma. Okay, so you're just distributing x is in A over all the sets. X is or over all the statements x is in B gamma, because this statement means either x is in B1 or x is in B2 or x is in B3 or x is in B4 and so on. So just in a general scenario. So you can distribute x is in A the same way as you distribute this in two sets. So that's just x is in A and x is in B sub gamma. So you're distributing it for some gamma. All right. So again, that's just distributive law. But inside the statement, we have x is in A and x is in B sub gamma, means x is in the intersection for some gamma in the indexing set. That's the definition of intersection. But because this is for some, meaning each set here, there exists such set such that the statement is true. So you can find as a gamma such that this statement is true for some. So meaning that's an arbitrary union. So that means x is in the arbitrary union of these elements here for all gamma in the indexing set. So yung for some, that becomes the arbitrary union. That's the definition of the arbitrary union. And so we are done because that's what we want to show. Therefore, the first set A intersection the arbitrary union, the union B sub gamma for all gamma in the indexing set is the same as you get the intersection of A with each of the set and then you get the arbitrary union. And so we're done. For example, remember our set. a while back, we have the set 0, 1 over n for our a sub n rather. Yan. A sub n is equal to 0, 1 over n. So what if we want to get the intersection of 0, 1 over n with, let's say, negative 1 half up to 1 half. Let's say a is equal to negative 1 half up to 1 half. So we want to get the intersection of a and an. And then after we get the intersection of all this set, we want to get the arbitrary union. Get the union for all n in the set of natural numbers. So what happens is this. So meron tayong, let's say a1 is 0 to 1. So that's a1. And then we have negative 1 half up to 1 half. So this on the other hand is our a. So a is fixed. So what's a1 intersection a? So a intersection a1 is the same as 0 to 1 half. Right? Now how about intersection with a2? a2 is 0 to 1 half. So this is a2. 0 up to 1 half, not including 1 half. But a1, sorry, a1, a also not includes 1 half. Oh, ganito na lang. I will just include it para hindi ko nabuburahin yung yan. So, intersection of 0 to 1 half and negative 1 half to 1 half, of course, the result will be, so 0 is not included in a1, so this should be not included. So, a intersection a2 is 0 up to 1 half as well. But this time, it's not including 1 half. Okay. Now, how about a3? a3 is 0 to 1/3. So, a3 is 0 to, let's say, this is 1/3. So, what's the intersection of a and 0 to 1/3? Of course, that's 0 to 1/3. And so on. So, you're getting all those intersections and that you get the union of all those intersections. But, the theorem is saying we can do this another way. This is also the same as a union with the arbitrary, or rather, arbitrary, what's that? Union outside, intersection inside. Union outside, intersection inside. So that's the same as a intersection, arbitrary union. So that's the same as a, and then the intersection of arbitrary union. So the union of all n from natural number. Now, let's see. Ano ba yung a? A is negative 1 half up to 1 half. Then you intersect it with, now what's the arbitrary union? Remember, our a is a shrinking set. So what's the union of this shrinking set? Since this is shrinking, at kinukuha natin yung union, this is a1 is contained a2, this contained a3. So pag kinuha mo yung union, that means that's the original set, di ba? Yung pinakamalaking set yung magiging union. Kasi palit lang naman ng palit eh. So pag ni-union mo silang lahat sila contained sa A1. So that means the union is A1. This is actually equal to 0 to 1. So that means dalawa lang yung kailangan mong i-intersect. Negative 1 half to 1 half at saka yung 0 to 1. So what's the intersection? Of course, that's 0 to 1 half including 1 half. And that's much easier than this whole thing. So that's how we use distributive law. And De Morgan's law is similarly used in arbitrary union or arbitrary intersection.